Today's Zoom session is being brought to you by the Fractal Black Rose. So, for today, simplifying complex fractions. A complex fraction is a fraction made of fractions. Here's 2/3 divided by 5/7. Here's the reciprocal of sum of reciprocals, an operation I call reduction, and there's an extra credit set for it in the extra credit module. Is 2 over x plus 5, all divided by 3 over x plus 1. The idea is we can simplify these by reducing them to a simple fraction. So here we have a fraction over a fraction, a over b divided by c over d. Yes? Okay. Dividing by a fraction is the same as multiplying by its reciprocal. Dividing by c over d is times d over c. So a over b divided by c over d will be a over b times d over c. Then you multiply across ad over bc. So for example, 2/3 over 5/7, that's 2/3 times 7/5. 2 times 4 is 4, times 7 is 14. 2 times 5 is 15. So 14/15. All right. Here's 8x to the 5th over 35y to the 2nd, divided by 2x to the 8th over 21y to the 5th. Well, that'll be the numerator. 8x to the 5th over 35y to the 2nd, times the reciprocal of the denominator. That'll be 21y to the 5th over 2x to the 8th. All right, so you multiply 18 times 21 times x to the 5th times y to the 5th in the numerator, 35 times 2 times y squared times x to the 8th in the denominator. After some cancellation, the coefficients is 27 over 5, and x to the 5 over x to the 8th leaves x to the 3rd in the denominator. Y to the 5th over y to the 7th leaves a y to the 3rd in the numerator. So you get 27 y to the 3rd over 5 x to the 3rd. Just a second, is there someone? Aguilar and Dixon. Okay, I see you were here. Thank you. All right. There's also, for more complicated things like reduction, there's what I call rescale by product of inner denominators. What I mean by inner denominators are the denominators of the fraction within the fraction. So here you have the inner denominators x and y. And we rescale by multiplying above and below by the product of inner denominators, xy, xy. In the numerator, you get xy. Distributing xy in the denominator, you get xy over x plus xy over y. After some cancellation, you get y plus x in the denominator, xy in the numerator. So xy over y plus x. Here we have 2 over x plus 5 divided by 3 over x plus 1. Here the inner denominator is x, so we multiply above and below by it. 2 over x plus 5 times x is 2 plus 5x. 3 over x plus 1 times x is 3 plus x. So 2 plus 5x over 3 plus x. Here we have 1 over a minus 1 over b divided by a over b minus b over a. All right. Inner denominator is a, b, so we rescale by ab. And 1 over a times ab is b minus 1 over b times ab is a over b times ab is a squared minus b over a times ab is b squared. A squared minus b squared is a difference of squares. A minus b times a plus b. Numerator is b minus a. These are not quite the same. They're in reverse order, but that just means that this, b over a, is the opposite of a minus b. Now the a minus b's cancel, and we're left with -1 over a plus b. All right, so some examples. 2/3 divided by 3/4. That's 2/3 times 4/3. And multiplying out, you get 8/9. 1/2 times 3/4 plus 3/4 over 3/2 plus 1/4. The inner denominators are 2 and 4. You don't really need to multiply by 2 times 4. Multiplying by 4 will do because that'll cancel the 2. So 1/2 plus 3/4 times 4 makes 4 halves plus 3 times 4 over 4. All that is divided by 3 halves times 4 is 3 times 4 over 2 plus 4 fourths. So this is a 2. 3 times 4 over 4 is a 3. 3 times 4 over 2 is a 6. 4 fourths is a 1. 2 plus 3 over 6 plus 1 comes out to 5 sevenths. Here we have 1/4 plus 1 over y plus y over, all that over y over 3 minus a half. The inner denominator is a 4, y, 3, and 2. We need the least common multiple, a common multiple of all of them that's as small as possible. Of 4, y, 3, and 2, what works is 12y. 4 goes into it, y goes into it, 3 goes into it, 2 goes into it. So I'll multiply numerator and denominator by 12y. 1/4 times 12y, 12y over 4 is 3y. 1 over y times 12y is 12y over y is 12. Y over 3 times 12y is 12y squared over 3 is 4y squared. Minus a half times 12y is minus y over 2 is minus 6y. So 3y plus 12 over 4y squared minus 6y. One over y minus 5 over 2 divided by 3 over y. We need the least common multiple of y, 2 and y. 2y does it. So rescale, multiply above and below, by 2y. 1 over y times 2y, 2y over y is 2. 5 over 2 times 2y, 5 times 2y over 2 is 5y. 3 over y times 2y is 3 times 2y over y is 6. 2 minus 5y over 6. 1 over y minus 3 over 5 over x times plus 2. Multiply above and below by x. 1 over x minus 3 times x is 1 minus 3x. 5 over x plus 2, all that times x is 5 plus 2x. 1 minus 3x over 5 plus 2x. Here I have 1 over 6, 1/6 minus 2 over x. All that divided by 1/6 plus 1 over x. Here the lowest common inner denominator is 6x. So multiply above and below by 6x. And this times 6x is x. 2 over x times 6x is minus 12. 1 over 6 times 6x is x. 1 over x times 6x is 6. So x minus 12 over x plus 6. Well, okay. 10 over x minus 3 divided by 6 over x minus 3. This is a simple fraction divided by a simple fraction. We multiply the numerator times the reciprocal of the denominator. The x minus 3's cancel. We have 10x over 3. 2's cancel. We're left with 5x over 3. Here you have m over n plus n over m divided by m over n minus n over m. And the main difficulty here is not confusing the letters m and n. All right. The inner denominators are m, n, and m, so multiply above and below by mn. This times mn is m squared plus n squared. This times mn is m squared minus n squared. You have 2 over c squared, all that divided by 1 over c plus 5 over 4. The inner denominators are c squared, c, and 4. The least common multiple of those is 4c squared. C squared goes into it, c goes into it, 4 goes into it. So multiply above and below by 4c squared. 2 over c squared times 4c squared is 8. 1 over c times 4c squared is 4c. 5 fourths times 4c squared is 5c squared. So 8 over 4c plus 5c squared. Wonder what that was. Anyhow, I think we already did this one. I call it reduction. Reciprocal of sum of reciprocals. Multiply numerator and denominator by xy. And after a bit of calculation, get xy over y plus x. Here we have m minus 1 over 2m plus 1. All that over 1 minus m over 2m plus 1. Okay, multiply above and below by the inner denominator, 2m plus 1. M times 2m plus 1 here, minus, this times this is a 1. 1 times 2m plus 1 here, minus, this times this is an m. So you get 2m squared plus m minus 1 over, after some simplifying, m plus 1. This, after some AC factoring, comes out to 2m minus 1 times n plus 1. All that's over m plus 1. Now the m plus 1's cancel, and we're left with 2m minus 1. All right, that's it for this one.